Okay, Ryan, let's see if this works. So for the image problem, first thing you want to look at is the size of the moon and the size of the Earth and how far away they are. So the diameter of the moon is 2,160 miles. So its radius is half that, and that'll be useful later. So it's about 1,080 miles. The diameter of the Earth is almost 8,000 miles. So it's 7,926 miles. So its radius is half that. That's 3,963 miles. So almost 4,000 miles. The distance from the Earth to the moon, if my camera would focus, is 239,000 miles. Okay? So if I go over here, if this is the Earth, this is the Earth, and this is the moon. If you were standing on the surface of the Earth, and you wanted to take a picture of the moon, or even if you just want to look at the moon subtends an angle like this. And that depends on the radius of the moon and the distance from the center of the moon to the edge of the Earth. So, it's just a simple geometry problem. So, this distance here, remember, is when they give you the distance between the Earth and the moon, they give it from the center to the center. So I told you that this radius is about 4,000 miles, and the distance from this center to this center is 239,000 miles. So the distance from this spot to the center of the moon is 235,000 miles. So I just took away 4,000 miles. So 235,000 miles. And so I'm looking at just this half angle, and by definition, the tangent of this half angle is this radius divided by this distance. So this radius is the radius of the moon, which is 1,080 miles, and divided by 235,000 miles. The tangent of that angle is a very small number, 0.046. If I do what's called the inverse tangent, which is on your calculator, it's a tangent with a -1. That just says, if I put this number in there, it'll give me the angle. So I take the inverse tangent of 0.00460, I get 0.26 degrees. That's this half angle here. So if I double that, that gives me 0.52 degrees. What that means is if you're standing on the edge of the Earth and you're looking up at the moon subtends an angle of about 1/2 degree. It's really small. It looks bigger than that to your brain, but that's just because your brain plays tricks with you. But we won't get into that. Now if I do the same thing from the surface of the moon, like the astronauts did, then I'm going from this distance here and then this angle. And so that distance is 238,000 miles, because I'm only taking away 1,000 miles from the center of the moon. And then this radius of the Earth is about 4,000 miles. So if I take that number, 3963, that's the radius of the Earth, divided by the distance, 238,000 miles, I get a number, a very small number, 0.01665. If I take the inverse tangent of that number, I get almost a degree, 0.954 degrees, which means that total angle is almost 2 degrees, 1.9 degrees. So that means if you're standing on the moon looking at the Earth, it subtends an angle of almost 2 degrees. Where if you're standing on the Earth looking at the moon, it subtends an angle of only 1/2 degree. So that tells you that if you're on the moon looking at the Earth appears almost 4 times bigger than the moon does when you're standing on the Earth. Okay, so now it just comes down to photography. So you take a picture from the moon, the Earth's going to look really big because they're not zooming in probably. They can probably just take a normal picture, just like you would take. And when you take a picture of the moon from the Earth, it looks whatever size you decide to zoom in on with that lens. Okay, now to the other question. So from that Discovery satellite, which is, it's actually, I looked it up, it's 1 million miles away from the Earth. 1 million miles. It's a long way. Getting a lot of shadows here. Hope you can see this. So I used this graph paper and I counted out the little squares, and I made each square, I think, 20,000 miles. And you can see here, if the satellite was here and the Earth was here, then the moon is way over here, 235,000 miles away, about a quarter of the distance from the Earth to that satellite, which is 1 million miles away. And you can see that I drew the circles to scale too. See how small the Earth looks from 1 million miles away, and the moon? But see, from this guy, in order to take a picture of the Earth and the moon, it has to have a super strong camera. It has to zoom in a lot. And it's going to zoom in a lot to see this moon. It's going to zoom in a lot to see the Earth. And when it does that, the Earth looks about 4 times the size of the moon. Just like what I described. But just because the radius of the Earth, or the radius of the Earth is 4,000 miles, and the radius of the moon is 1,000 miles. So if you had a strong camera from 1 million miles away and you zoomed in, you're zooming in on both these guys, and you'll see the moon pass in front of the Earth, and it'll look a quarter of the size of the Earth, because you're looking at it from so far away. Whereas when you're on the surface of the moon, looking at the Earth, you're just looking at it the same way you look at the moon from the Earth. So I hope that makes sense. Bye.